This is Radio Health Journal. I'm Reed Pence. This week, where organ transplants will come from in the future.
The potential of using pigs is enormous. We're talking particularly of kidneys where there's a long waiting list. Patients may wait 7 years or longer on dialysis waiting for a human organ.
Saving human lives with pig organs when Radio Health Journal returns.
I'm Nancy Benson, host of Radio Health Journal. If you enjoy Radio Health Journal, you'll also like our sister show. Here's a preview of what they're covering on Viewpoints this week.
This week on Viewpoints.
Many people have spent many years and a lot of money looking for Captain Kidd's buried hoard, but none of them have found it, and none of them will.
The epic history of America's most notorious pirates. Then,
a true revolution in writing technology is changing how we communicate, and that also changes what stories we tell.
The power of stories to shape people, history, civilization. I'm Marty Peterson.
And I'm Gary Price. These stories in depth this week on your public affairs magazine, Viewpoints.
Listen to Viewpoints on your favorite radio station, iTunes and Stitcher.
More than half of all Americans are signed up to be organ donors, yet the supply of transplantable organs has no hope of keeping up with the demand. Only 3 people in 1,000 die in a way that would allow their organs to be donated. So while more than 110,000 people are on the National Organ Transplant waiting list, fewer than 40,000 transplants are done each year. 20 people die each day waiting for an organ. Doctors have considered alternatives for decades. Mechanical hearts, for example, have been tried. But now doctors think they're close to a solution. Before long, organs for transplant may come from the same place as your breakfast bacon, pigs. It's a process called xenotransplantation. Dr. David Cooper is professor of surgery at the University of Alabama at Birmingham and co-director of UAB's Xenotransplantation program.
Xenotransplantation is the transplantation of organs or cells or tissues between animals of different species. And obviously for clinical research and clinical future, we're interested in an animal that we can transplant the organs into humans to resolve the shortage of human organs, deceased human organs.
A lot of people's first experience hearing about xenotransplantation came 35 years ago when a newborn girl known as Baby Faye received the heart of a baboon. She died 3 weeks later when the heart was rejected, but Baby Faye was considered the first successful heart transplant of any kind in an infant. It was a long time coming.
Before Baby Faye, pretty well all the transplants done in humans going back to the beginning of the 20th century, 1900 or thereabouts, were transplants of organs from non-human primates.
That idea made sense. Baboons and chimpanzees are genetically much more closely related to us than any other species. And for a while, it looked like that's where organs might come from. In the 1960s, doctors at Tulane University transplanted chimpanzee kidneys into human patients.
It was at a time when dialysis was not available to most people and when organ donation was very difficult, and he had patients dying of kidney failure, and he carried out 6 transplants. He put both kidneys from the chimpanzee into the one patient, and most of the patients died, unfortunately, after about 6 weeks, either from rejection or from infection related to giving too much immunosuppressive therapy. But one patient lived for 9 months, and she went back to work as a school teacher and then suddenly got sick and died within a day or two. It was thought from an infectious complication, but for nearly 9 months, the chimpanzee kidneys kept her alive and well, suggesting that if we use chimpanzee kidneys today, with the much better drugs we have available today, we would do very well.
Despite that, Cooper says doctors turned away from non-human primates as an organ source. For one thing, primates seemed ethically suspect. Chimpanzees also never get to be nearly as big as people, so their organs would be undersized. So why not pigs? We've used pig heart valves for transplant for 50 years, and for whole organs, they're the right size and avoid a lot of other logistical problems as well.
If you breed baboons, they breed in ones or twos. You breed pigs, they breed in 8s, 10s, or 12s at a time. The baboon takes about 9 years to grow to full size. The pig is the same size as an adult human within 6 months. So logistically, the pig would be much more suitable if we want a source of organs. The public would be much more likely to accept the pig as an organ source than the non-human primates, because we've been used to using pigs for food and for other purposes, heart valves, for example, for a long time. We use more than 100 million pigs each year for food in the United States. And in China, apart from food, they slaughter 500 million pigs to provide heparin, the drug, the anticoagulant drug heparin, which you take from the liver and so on.
Non-human primates aren't out of the experimental process completely. They're still the closest relatives we have. But now they're used not as donors, but as a stand-in for human recipients.
From an experimental point of view, we use a non-human primate, such as a baboon, as a surrogate for the human. So we use pig-to-baboon transplants as a basis for one day going into pig-to-human transplants. The baboon's immune response to a pig organ is very similar to a human immune response.
Sometimes that immune response doesn't create trouble. We've mentioned pig heart valves.
The heart valves are treated with certain sort of chemicals so that to some extent their tissues are protected against this immune response. However, there is increasing evidence that they are eventually rejected by the same immune response as rejects the pig's heart or kidneys and so on. But it takes a lot longer. In young people, like teenagers, if you put in a pig valve into the patient, it will be destroyed within a year or two, because the immune response is much more vigorous in young people. If you put it into a patient who's 60 years old, it may last 15 to 20 years, because the immune response and the metabolic response is much weaker. So there are significant differences between simple pig tissues like a valve, which has really got very few living cells in it, and it doesn't have to do much, it's a passive thing, than it is to put in a heart or a kidney that has to function normally in the foreign environment of the patient's body.
And unfortunately, while the immune response to valve tissue is small, the reaction to whole organs is swift and violent.
We found, as other people had found before, that if you put a pig organ into, say, a baboon or into a human, which has been done in the past, it's rejected within minutes. Literally within 5 minutes it's rejected. And the reason it's rejected is that we have antibodies against pigs. And we develop them during infancy. We don't have them at birth, but we develop them soon afterwards.
You'd think that would be a deal breaker. So what if pigs are plentiful and the right size, if their organs are rejected immediately? But apparently that's the breakthrough that makes the whole idea possible. Scientists have been working on the problem of rejection for 35 years, and Cooper says they're on the verge of solving it.
The only way we've been able to do this is by genetically engineering the pig. But we must remember this is the first time in transplantation that we've had an opportunity to modify the donor as opposed to just treat the recipient. All we've done up to now is to give the recipient more or better immunosuppressive drugs. Now we have the opportunity of doing things to the donor, and the more we do to the donor, the less we'll have to do to the recipient. So in the long run, I think xenotransplantation will be a much better option for patients than human organ transplantation is at the present time, because we will get to the point we can do almost everything in the donor to protect those organs from the rejection, and therefore we have to do less for the patient.
The idea behind the alteration of pig genetics is simple in concept, but extremely complicated in execution. Scientists target the genes producing antigens that our immune system responds to, leaving nothing to react against. Researchers have also knocked out potentially dangerous viruses that inhabit the pig genome. And by crossing two such pigs, presumably those genetic characteristics would be passed on to subsequent generations, growing the supply of organs.
We know of 3 carbohydrate antigens, and we have now pigs that don't express any of them. So there are no targets for human antibodies to bind to which initiates the rejection. So, and we haven't tested these in baboons yet, but we've tested them in the lab with cells and so on, and there is no antibody binding to these cells and no destruction of the cells. So we believe this is going to be very important.
Researchers writing in the journal Nature say they've used genetically altered pig hearts to keep recipient baboons alive for more than 6 months. But there's lots more work to do before the FDA gives the green light.
They want us to come back with a series of transplants to show that these pigs will provide organs for fairly long-term survival and that will be effective, etc. We already know that pig kidneys work very well in baboons, so there's no reason they shouldn't work well in humans. They do pretty well everything we want a kidney to do, same with the heart and so on. And so I think we're getting very close to the point that we would be able to, with highly carefully selected patients, we would be able to offer them a pig kidney as an initial clinical trial.
Cooper says that at first, patients would have to be carefully selected. Perhaps surprisingly, he says among those considered the best patients for pig hearts would be newborns.
Newborns who have very complex and life-threatening congenital heart disease, they're born with defective hearts. It takes them several weeks or months to get a donor organ, and most of them will die during that time or have to have some palliative surgery, which is less than optimal. So we feel that, and yet assist devices and mechanical devices are not very effective in babies of this age. So we believe that would be a group that would certainly benefit from a pig organ transplant. Maybe initially just as a transplant to bridge them until they get a human graft, because we don't know how long the pig graft will last. But as long as we're pretty sure it's going to last a few months, we could put a pig organ in, and then when a suitable human organ comes available, we change them over.
However, eventually pig organs won't be just for a few cases here and there. Cooper believes they'll be a major player in transplantation for millions of people.
The potential of using pigs is enormous. Not only could we take all the organs, and we're talking particularly of kidneys where there's a long waiting list. Patients may wait 7 years or longer on dialysis waiting for a human organ. And at a certain age, 60s or so on, the patient may not survive 7 years on dialysis. So those are patients who might well choose to have a pig organ because it's available immediately and it should keep them alive at least for some of that period of time. We don't yet know exactly how long.
Livers and lungs could also be in demand as transplants. And for people with diabetes whose pancreatic islet cells no longer produce insulin, pigs offer relief.
If you put a pig islet cells, pig pancreatic islets into a diabetic monkey, for example, we and others have had complete cure of the diabetes for up to one group for more than 3 years, and we've had it for more than a year, and then we euthanized the monkey. And we're talking here not of 100,000 people on the waiting list for an organ transplant. We're talking of 1.5 million people with type 1 diabetes in the United States and about 30 million with type 2 diabetes. And worldwide, we're talking of more than 100 million patients with diabetes who could benefit from having a pig islet transplants, which is a much simpler thing, of course, than an organ transplant. You can just inject the islets into the portal vein or into some other site.
Doctors admit that for some people there will be a little squeamishness at the prospect of having a pig organ inside their body. But the prospect of having your life saved when there's no other way eliminates the objection pretty quickly. In the next couple of years, small clinical trials are likely on humans. If those pan out, they'll be expanded. And at some point, pig organ transplants may even become routine. You can find out more about all of our guests on our website, radiohealthjournal.net. I'm Reed Pence.
A first-of-its-kind preclinical study shows that lactating rodent mothers taking supplements of a rare form of vitamin B3 called NR, or niagen, enjoyed significant health benefits. And their offspring did too. The study in the journal Cell Reports found that mothers supplemented with NR produced more milk and lost more weight than control animals. Mother's milk contained more of a molecule known to promote neuron growth. Offspring showed better neurobehavioral development even into adulthood. Dr. Charles Brenner of the University of Iowa discovered NR and was principal investigator.
In a 15 years since I discovered NR as a vitamin, I've been continually impressed by the power of this molecule to address metabolic health. Based upon our newest research, Niagen has great potential in the areas of women's and family health.
Previous studies have shown that in middle-aged and older adults, Niagen raises body levels of the coenzyme NAD, which is essential for cells to process energy. Find out more at aboutnad.com.
Individuals and businesses with tax problems, listen carefully. Do you feel like you're losing control of your finances? If you owe over $10,000 in back taxes or have unfiled tax returns, we can help you take back control. The IRS is the largest and most aggressive collection agency in the world, and they can seize your bank accounts, garnish your paycheck, close your business, and file criminal charges. Take control of your tax problem now by calling the experts at U.S. Tax Shield and take advantage of the Fresh Start program and new laws that may allow us to negotiate a settlement for the lowest amount possible. Our team of tax attorneys and enrolled agents can stop collections and get you protected so you can take control of your financial future. U.S. Tax Shield offers a price protection guaranteed quote to get you protected today. U.S. Tax Shield is A+ rated with the Better Business Bureau, so call now. 800-568-1647. That's 800-568-1647. U.S. Tax Shield. 800-568-1647.
What are you going to do with your old car? You can try selling it, you could junk it, or you can donate it to Heritage for the Blind. Your car will be towed away for free and your donation is tax deductible. Just call 1-800-835-1478. Heritage for the Blind accepts cars, vans, trucks, and boats. It doesn't matter if your vehicle runs or not. It will be towed away for free, and you'll be supporting those that need help. Heritage for the Blind is a nonprofit organization that helps the visually impaired live fuller lives. Call right now to donate your car, and as a special thank you, you'll receive a free 3-day vacation voucher to over 50 locations. Call Heritage for the Blind right now. Call 1-800-835-1478. Donating is easy, and your vehicle is towed away for free. Plus, you'll get a free vacation voucher for donating. Call now, 1-800-835-1478. That's 1-800-835-1478.
Thank you for listening to Radio Health Journal, a production of MediaTrax Communications. If you enjoyed this week's show, please leave a review on iTunes or share it with a friend. You can find more Radio Health Journal stories about health, science, and technology on iTunes, Stitcher, and at radiohealthjournal.net.